This video will give a quick overview of basics of Python programming. So we are starting Python and a quick overview is given. So we will cover Python version 3.4. From where you have to download it, the path has been given. And note that there is an excellent tutorial at this path. You may like to go through it. So when you run the Python, how do you run the Python? Let me explain on the command prompt. Okay, so we have a command prompt. Maybe you simply run the command Python, and if Python is installed successfully on your system, then you will get a prompt like this. A prompt having 3 angular brackets. So this is the Python interpreter's prompt, and all it is saying is that it is ready to execute your commands. For example, you may say the first program print hello world. So print is a inbuilt function and it simply prints hello world. Anything included between 2 double quotes is a string. In fact, instead of a double quote, you may use a single quote and you would still be right. These 2 strings are equivalent. Okay, so that's how to start the Python, and you can always observe the version. In the output, you can observe the version always. Okay. So Python is quite easy to learn. There are excellent tutorials available. It is an interpreted language. That means the interpreter converts one statement at a time to machine code and then executes it. It is object oriented. Almost all data types you see in Python, they are actually classes. So what is a class? Class is a collection of data and behavior. It is like coupling the data with the behavior. We'll have more to say about object oriented later. It has very powerful built-in data types. If you look at the kind of operations you can do on the data types, it is very powerful. So that leads to smaller programs doing a larger amount of work. It is very high level language. What do we mean by very high level language? So let's say assembly is a low level language, C is a high level language. So Python is very high level in the sense that it has higher level data structures. For example, there are inbuilt list, there are inbuilt set, there is a inbuilt mapping called dictionary. There are such data structures. So it is very high level. Whenever you learn any new language, typically your focus would be these 3 or 4 things. You would know what are the different data types, how to declare the variables. In fact, in Python we will observe shortly that there is no need of declaring the variables. When you use them, they are created. We will see. There are execution statements and there are control flow statements. Control flow statements could be if then else, could be for loop, while loop, etc. There has to be some means of taking input and output from the user, and there would be some means to create functions if you are doing structured programming, or create objects if you are doing object oriented programming. Functions would be required in object oriented programming also, because ultimately every object would store some data and would provide some functions. So this is the Python prompt and something is being demonstrated. It is very much advisable that you stop the tutorial time to time, maybe pause the tutorial time to time, and on the prompt just try what is being shown or maybe related things, and then resume with the video. That way the learning will be maximum. So let me do it on the prompt also, that may be more nice. So let's say we create a variable x equal to 20. We have just created a variable of data type int. The data type is int, it's an integer, and the value is 20. So you can verify that it is 20. you can choose to assign a different value to the same variable, and now the data type of x has changed. So neither we needed to declare the variable nor a variable is tied to one data type. It can take different values of different types. So that's what being shown on this slide. We have demonstrated also. Variables need not be declared, can change type dynamically. So this makes Python quite compact and convenient. These are the data types which we will see. There are atomic data types. Atomic means they store a scalar value, they store one value. And there are collection data types. Collection means they store more than one value. So we will see int for integer, float for floating point which has a decimal point, bool for boolean, decimal again for floating point but it supports some other kind of functions. Fraction is a numerator divided by denominator kind of number. Complex number we know. Collection, list, string and tuple, these three happen to be ordered sequences. They are all sequences. Sequence means one item, then the next item, then the next item. So these three are sequences: list, string and tuple. We will see what they are. We will see how they are used. Set, the order doesn't matter. Set you can relate to a mathematics set which you would have studied in the high school. So the order doesn't matter. Dictionary is typically a mapping from some key to some value. Maybe you are storing phone numbers of people, so you are mapping name to phone number. So these data types we will quickly see and see it on the terminal also. Integer and float, these are the kind of operations you can do: addition, subtraction, multiplication, division. There are two kind of divisions. One gives a integer result, this actually gives the integer result, and one gives a floating point result, something like that. We will see on the screen. Double star is exponentiation. It may be surprising, but it so happens that even these int and float happen to be classes. You can use the notation x dot member on these also. So let's see in action these operators, although they are explained in this slide, but let's do it on the screen also. So let's say we create two integers, give them some values. So we can multiply them, we can add them, etc. We can do division. By default, division in Python version 3 gives a floating point result. But if you use the double slash, then it is like a integer result. So it comes out to be 0. So essentially the decimal part is discarded. You can do a exponentiation. For example, you can say 3 to the power means star star, that is operator, 3 to the power 4. So the result is 81. Okay. Then we have the Boolean. Boolean basically means that there are two values, true and false. So you can have the variables and you can have operators operating on them, and, or, not. So you can have, for example, conditions x less than 10. Right now what is the value of x? 10. Okay, x less than 10 is false. X double equal to 10, yes, true. X greater than 10, false. What is the value of y? 20. Okay, you can have composite conditions, x less than x equal to 20 and y equal to 10. That's false. The right is x equal to 10 and y equal to 20. That's true. So you can combine conditions, etc. So and or not, these operators are there. You can play around on the prompt, you can convince yourself, you can look at the PPT and understand what these means. Best is to do it on the prompt and then relate it to the theory. That is the best way. So where would you be using such things? What is the reason of these logical expressions? Typically you use them in condition, in any construct which involves a condition, true or false. For example, you may say if x equal to 10, then print x is 10, else. Okay, so I made a syntax error. I should have written else colon, never mind. If x equal to 10 colon, that is the syntax, print x is 10, else colon, remember that colon, and then I must indent, and I must indent to the same level. I will tell soon. And I can say print x is not 10, and it is still giving the continuation prompt, dot dot dot. Continuation prompt means it is asking for more code to be entered. It is not yet complete. Because we are complete, so we will press enter, indicating that we are done, and you can see x is 10 is printed. So you could have given any complex condition here. In fact, you could give a integer or a string or a list also here, and any non-zero integer is true, any string having non-zero length is true, any sequence like list having non-zero length is true. That is how these data types map to the Boolean space. We'll see these constructs if then as more in later sessions, but there is no harm in seeing them early also. Okay, so these are the kind of logical operators. That's fine, you can experiment, see all of them. Let's see the collection data types, which are collection of things. So let's understand the list first. List is a ordered collection of 0 or more objects. The objects in theory can be of different types, but more often than not they are the same type. So let me show it on the screen. Let's say we have to create a list of marks of students, so I can have such syntax. So some number of integers included in square brackets. So x is a list data type. X is a list data type. So there is a notion of first element, second element, third element, and the index starts from 0. So you can actually use the subscript operator. This square bracket is the subscript operator to access the integers. So you can say x0 and it prints the first element. You can say x1, it prints the second element, and so on. If you give an index which is out of range, Python has error checking, excellent error checking, and it throws an exception and you see an error. So in general, as I said, list can be of different data types also, but more often than not you will find them of the same uniform data type. So you also see the syntax of for loop here, although we will cover for later, but it's easy to understand. For, then some variable name which will take different values of the sequence, take 30 first, then 50, then 45, then 60, 70, 80. For some variable name in, then the name of the list, colon. Colon is used as the last character of if, for, while, and maybe some other constructs and print item. So let's do it on the prompt also. We have the list X, so let us iterate through X. So maybe we say for I in X, maybe we want to print I comma I star I. Maybe we want to say what is the square of each. Okay, so we press another enter to indicate we are done, and it prints the integer as well as the square of it. So for loop also we have had a glimpse now. List has various operators on it. Let me explain. There is a concept of slicing, okay, something called slicing. So you can say that give me the sub list of this list starting with index 1 and ending at index 3 but not including index 3. So okay, sorry, I made a syntax error. I should have said x1 colon 3. Sorry about that. Okay, so you get a sub list. This was the original list, and you get a sub list. What is that sub list? All the elements starting at index 1, that means starting at 20, and index ending at index 3. So index 3 means the fourth element 40, but 40 is not included. So it is like start is included but end is not included. You can give the slicing in various ways. 1 till end, everything till 3, omitting either the start or the end, and even omitting both. That simply makes a copy of the whole list. Okay, so there are so many operators on a linked list. You can say length of X, which simply gives the number of items in it. You can do various operators, like you can check 14 in X false, 10 in X true. So many things you can do. And what I have shown is only a very small subset of the different things. So you should refer to some reference resource while programming to know what all you can do on a list. The same operator plus, which adds to integers, can be used on lists also, and naturally this plus has to have a different meaning. It concatenates those lists. So for example, if I have a list, if I have two lists X and I create a list Y also, maybe give it some number, maybe negative numbers this time. Okay, so X plus Y is a concatenation of these two lists. One can also say X star 3 star 2, for example. It says to repeat the list twice. So the same list 10 to 50 has been repeated. Okay, so it comes 2 times. You can have a nested list. So in this example, Y is a list of lists. Okay, so naturally if Y is a list of lists, then Y0 happens to be the first list. So syntax like this can be understood. Y0 happens to be the first list, and Y0 is a list of integers. Y0 is exactly this highlighted stuff, and on that thing you can apply a subscript 1, that means give me the second element, which is 12. So you can see 12 is given. So you can satisfy yourself that these syntaxes are valid, and these are the kind of things, these are some kind of things which you can do on lists. Okay, let's stop this tutorial here, and in the part 2 we will continue.